Yeah, yeah, yeah. All right, an overview. This is the best picture I found that I could copy, but it doesn't matter. Point is, there's some people on the ground and they're operating the drone. And then you have something in the air that is flying. Well, you need some kind of communication with the drone. That is like the first part. And then we'll start looking at the system that you can need. But the idea is that you somehow want to control the drone, and that is done via like two modes really. First of all, it is you're manually flying it. That would be done with a remote like this, and then you would move the sticks, fly it, kind of like a car. You just don't have gas and steering wheel, but you have four sticks. But if you would have, like, let's say, but a drone car, you would literally have a gas and a steering wheel. But you can also have something that is called a ground station. Now, that is basically just a computer that you can interface with, and then you're kind of asking from the drone a bit more. You want it to be able to fully fly on its own, and we will take a look at what you need to be able to do that. Most of the people call one of the drones like an autonomous drone, and the other one just a fucking, I don't know, Jenny, what do you call it? Something that needs a radio to be flown. I don't know. One of them is autonomous, the other one isn't. So yeah, you don't need a radio really for an autonomous drone. But yeah, the parts for the system itself, there's gonna be an autopilot or an FC. An autopilot is mostly like, I don't know, Yanni got me recently to say the same. It's mostly for only, what do you call it? Enterprise drones. Like, what do you call it? If it's fully autonomous and stuff like that, then you call it the autopilot. It's just a computer. It's a fucking calculator of the drone. If you need more from it, you need a bit more cores, but faster processor, that's it, you know? And you can buy the things off the shelf, you can make them, and you have, then we're gonna come to the next thing. You have firmware for them. This is a flight controller, an autopilot, doesn't matter, on the bottom, this thing. And this one is also technically capable of autonomous flight, but we don't usually call it the autopilot. Doesn't matter. Point is, it does the calculations, most of the calculations. It has an F405 STM chip on it. When you are hearing this F4, F7, H7, if you hear someone say F3, punch them, or F411, punch them, don't, like that is just like ancient history. We don't know anything about that. But yeah, F405 is kind of like the most primitive processor you can get away with while still be able to kind of do most of the functionality you need. Microprocessor. To run the firmware that you need. Now, why am I saying firmware? Do you know the difference between firmware and software? Firmware is basically an embedded code that you upload onto the usually single core microcontrollers. And then you just have to kind of like, the only thing you can really change parameters on that thing, it just runs the code. You don't have, what do you call it? You don't have something that can run over top on the thing. On a computer, we call it software. It has firmware already. I don't know what's the firmware. It's probably going to be something like, the BIOS is the firmware. Yeah. And then on top of that, you're running the software. So that's kind of flight controllers, and then yeah, software firmwares. We're gonna take a look at them. There's a bunch, massive variety. Because technically, you could be flying on a Windows computer if you really wanted to. I don't really see the point. It's probably the most stupid thing that I've said today. But yeah. PLCs. That's all the explanation you get. No, I'm joking. The electric speed controller, that is a special component used only for PLCs, pretty much. It's, yeah, I'll show you. It's purely electronics. Then we're gonna take a look at some batteries, some parameters over batteries, and some stuff like that. Radio systems. Now this is all communication with the drone is usually done by a radio, right? You could technically go into some other fucking fields, I don't know, like audio, shot at it, like go forward, I don't know. It's not very practical. Not many systems use it. But there are better drones. You could do the communication over the wire. You could do the communication over laser. That's also probably something someone is researching for some military use case. I don't know. But yeah, because we have the electric magnetic field, it's nice to just use radios for shit for communication. I'll just show you what is the most used stuff and the standards kind of. Then GNSS and other navigations, and we'll actually probably also touch up some other sensors that are used in drones a lot. And I'll explain what a ground station is, because the difference between Yanni's, what is it? Okay, what was it? Steam Deck and a ground station. I mean, it's like literally you plugging in one thing. So yeah, let's go and take a look at some autopilot shit. Now on the left, you have the big stock, 6C. It's like the cheapest big stock you can get. I think that the Mini is cheaper though. Yeah, I got it right. And that one you can already kind of call like an autopilot, you know. But point being, the only difference between those is the software. No, the firmware. The firmware. It can actually be the same firmware. Actually, just be set up a bit differently. But the differences are like minute. On the left, you're probably looking at, I don't know, it's probably an H7, maybe dual H7. I don't know. It's an H7. Okay. Maybe a better gyro, an accelerometer, and some components, electronic components. If you don't know what those are, that's not a problem. We're not going to go and take a look at those things today.
The biggest difference is redundancy.
Yeah, redundancy. And just ease of use. You can see how the the BISOC has like nice fucking points. If you are wanting to make like a system, if you want to be working on this exact fucking system for, I don't know, a decade, then a BISOC is probably just way better, just because, you know, fucking points on it. And the other one will have to be soldered, and it's actually the Speedy BF405. That one is the V4, V3. V5 sucks ass. Don't get it. China ruined them. You have to log in to be able to upload firmware. Apparently, I haven't tried it. But yeah, so different processors. They can run the same firmware. Usually, you have different firmwares that will show why they are different and how they work a bit later. But point being, it's kind of the same fucking shit. It feels how it moves, and then it calculates what it wants to do on the output ports. You usually plug in data connectors, both sensors and actuators. Nice, that is a fucking reference. Anyway, into the flight controller, or solder the fucking pins, and then it just calculates. It's a fucking calculator. And yeah, that's kind of it. Now, get your hands ready with those things. It's gonna be the thing, like that USB-C fucking board is gonna be used a lot, especially in the starting stages. You'll be plugging out that fucker like for a long time. Yeah, sometimes you're gonna be plugging in and not getting any response from the computer. You're gonna be like, what the fuck? Change the baud rate, change the ports, stuff like this. fuckers burn as well. That is another thing. That is a nice fucking feature of them. You can kind of sometimes you can feel what burns, check what burns. Quite often it's the regulator or the processor itself. If the processor burns, you can touch it. It's really fucking hot. That's kind of a done deal. Anyways, what could I? Yeah, you have a bunch of UARTs on these fuckers. I don't know. Arduino has one UART. The Uno or the Micro. There's one UART. You want multiple UARTs. My phone is chirping a lot. So you want a bunch of UARTs to be able to do a bunch of communication with fast sensors. That's kind of what you're looking at. Quite often, the thing is also that for communication, you want also to use, I don't know, like I squared C. They also have those ports. You can set up, like, you usually have different sensors that use different protocols for the communication. And you can set all that stuff up on the computer, then you either choose the firmware which can do what, or you change parameters in the firmware to be able to do different communications with different ports and so on and so forth. One thing that's, I touched up on, I'm also interested. Yeah, I touched up on UARTs, I squared C. What else do we use? CAN. CAN exists. It exists only on Delta files, pretty much. I have not seen. I've used CAN once. And I've done a lot with Go. CAN exists only on the big fuckers. If you need CAN, you probably already know what you're doing. And yeah. The more UARTs, the merrier. You can plug in more shit. The bigger the number is, the usually you have more UARTs. That's kind of how it goes. It's like computers. Bigger the number, kind of nicer it is. Sometimes it is. Yeah, 45 times 45. I've never seen that ever. Yeah, F1, F3, F4, F7. No, those are like, what do you call it? It's the microprocessor. You can actually see how it gets bigger. That is old fucking image. The F7 processors don't look that big anymore. And you also have H7 processors that are also nowadays very cheap. And they look, they're the same size that the F3s were back then. Maybe F4s. And point being is, the bigger the number, yeah, as I said, better the calculator. What can we talk about? 16 by 16 millimeter things, never seen. Usually you're gonna be working with something that is 30 by 30 or 20 by 20. 20 by 20, then you're probably working on a micro. You're probably not looking at a big processor or much of processing. Probably looking at something that is more hand-blown. However, there are some stuff that can run RU Pilot. I've not seen anything that can run PX4 on 20 by 20. You don't know what RU Pilot or PX4 is. I'll show you in a second. But that's kind of it. That's the flight controllers. Now, yeah. Then you can start adding on to the flight controller more things, and the more close it becomes to an autopilot. And also the more what do you call it? More specific it is for a use case. Now what you can see here is a stack. We call a stack basically just two PCBs stacked on to each other. And usually a stack is consisting of 4 ESCs and a flight controller. Back in the day, the ESCs were so big and so bulky, and they were not made for multi-rotor purpose at all. And you needed another electronic component that is called the PDB, Power Distribution Board, to connect the ESCs, electric speed controllers, together. So it just was a fucking big plate that had a big plus and a big minus. You connected the battery minus. Then you connect it to big pluses and big minus to each big pluses and big minuses of the ESC. It's kind of how it works. We kind of got rid of them when we realized we could put all of those ESCs onto one fucking PCB. So we got rid of 5, got turned into a 1. Back in the day, it would probably also be unpacks would be like 5 in 1 fucking electronic component and shit like that. But yeah, there was a transitional period. You don't really need to know this, but it's more of a fun thing. There was a transitional period where people were like putting together flight controllers, PTVs, and some other shit on the flight controller. So those are the things that you can see. But what's ended up happening realistically for 99% of the time is we got stacks that got, well, no RX usually. Yeah, OSDs were also back in the day different fucking shit. I'll tell you what an OSD is a bit later. But we usually have in the stack 4 electric speed controllers for 4 motors and a flight controller. So that is a stack. Boom. Our new pilot. PX4. I couldn't find a good picture for PX4. That's how cool it is. That's how, what do you call it, industry it is. So, these are a bunch of the firmwares. These are not all the firmwares. Some of the firmwares I haven't touched and heard of, like Libre Pilot, Open Pilot I've heard of. Dronin, never heard of. But yeah, Raceflight, Metaflight, Wingflight, INAV, KISS, Audio Pilots, and PX4 is kind of the main softs that had a relevance in drones. Nowadays, the main things would be Betaflight, fuck Cleanflight, no, Betaflight, fuck INAV as well. So Betaflight for everything that is small and needs to be hand flown. And if you need any automation on it, if you want to learn for yourself, you could go the route of going to INAV first and then go to Audio Pilot, but just skip the INAV part. There's no reason to just go to Audio Pilot or PX4 and learn that. So Betaflight, Audio Pilot, PX4, that's the main shit. Betaflight has the best, what do you call it, it's most bare bones, so it's like Arch Linux, it runs really fucking fast, does good filtering, doesn't have any features.
These were the money, right?
No.
Screw.
Okay. I don't know, fuck that. Point being, Betaflight can run quickly on very small chips. So F4s are great with Betaflight firmware running on them. You can't do autonomous shit. It has nothing in terms of, well, it does some autonomy. The code that was first written for autonomy, for like flying to a point was so bare bones that it was like, you literally look at 2 previous GPS points and you're like, okay, so we're gonna do a vector here, and if that vector is the same place that, somewhere where we're going is, then nice. If not, then you turn left. So that was a GPS recipe. It's actually ridiculous how simple it worked, but it worked. And Betaflight is kind of like hand-flown. It's easy to use because you have a nice software on the computer. I can actually show you as well. Do we have something to plug in to the project? Oh, nice. These were still on the firmware already, and probably overexplained a lot of shit. Alrighty. Probably gonna be a voltage cable or something. So, That is better flight. Apparently this board is running better flight set. Cool, that's it. Oh yeah, I did recommend it as well. So you can see that it's super simple, the GUI is super nice. You can even like open it on Chrome browser. Privacy policy, blah, blah, blah. It has, first let's go over about a bit of the simple stuff. It has a firmware flasher. That's basically when you go into the DFU mode, you can flash firmware onto the microcontroller. It will just ask you some basic shit. Okay. It can auto detect shit, which is nice, but if not, you just find the thing of all the flight controllers that you have. Which one do you have? We have the B4, nice. And then you just choose the version that you want. There's not, like, you can see that there are 4.3, you don't see pretty much, like, the older versions, they're just, a lot of them are kind of, like, useless. Also, some of them have bugs. Sometimes when you use the shit, it's like, it's open source shit, so kind of like feel out which one doesn't work. If it doesn't work for a very long time, maybe just go to a different version, maybe it will start working. And some of the versions have like normal bugs and shit like this. Yeah, then because it's so bare bones, you can add features and like, it's like the options or whatever. And then you can see that there's always like protocols you change, you don't even like, it doesn't even have it on the board when you flash the firmware. Now that is like a newer feature, back in the day it did. But now you have to reflash it so it runs even faster. Compared to the amount of features that it has. You can see like, you could technically take out a feature that is an LED strip. You're not going to be able to run LEDs. Do you need a lot of memory for storing LEDs? No, but it is already kind of impactful. Like this thing doesn't have a lot of memory, and stuff like that. Never seen that many features on fucking whatever. Let's replug it, and I'll show you the configuration kind of how it works. So now you can see that the thing is connected. Well, you check if it's actually connected. You move the fucking drone itself, and you have visual indication of the thing that moves. This thing shows you the z-axis. This thing I don't know why, and this just shows you the wrong y-axis. Now that's all just an accelerometer in general combined together. You can do the calibrations and stuff like that. I don't know, I'll show you the calibration. So I'm gonna have it wrongly positioned. It thinks it's normal, and I'm gonna put it back on. It's not normal. You get it, it's simple shit, right? You can configure the ports, all kinds of other stuff, it doesn't matter. Point being, super simple to use, super user friendly, compared to, and now I'm going to show you RDPilot and Mission Planner. RDPilot doesn't even have like a GUI for RDPilot. It has, yeah, but like, was it made by somebody? Okay, so okay, I'll show you Mission Planner, and I'll show you RDPilot. Actually, let's take with speed. RDPilot.com is yeah. It's open source. You can see how fucking old is the website. This is one of the most used fucking software firmwares in the world for drones. Maybe Phoenix, is it more popular? No, it's ridiculous. Like it's 2025. It's ridiculous. But yeah, that is RDPilot, and it works. It's trusted, versatile, it's beautiful. And then you have the documentation. So if you're gonna work with RDPilot, I will just show you really soon, why you will probably spend most of the time in the documentation rather than, I don't know, in the GUI and like testing stuff out, because there's so much shit. Just this is opening up mission planner. I'll bring the other Already proud. Point being, you could flash both of the same chip with different firmware, it will behave very differently. And so, update found. Do you wish to update? I don't know. At least it's not like DJI with like updates. Do you wish to not fly your drone? Shake is that was not a question. Yeah. Not true. Oopsie.
What was the X? We could just say our.
Okay, let's take a look at some code. So yeah, this is all built into Autopilot. Let's connect to the board. By the way, we haven't connected to the board yet, so. Okay, this column is kind of promising. It says Autopilot on the thing. And okay, let's just try it. Let's just try it. Why is it 9? What? Okay, nice. So now let's check if it's connected. It is actually connected. That's nice. Yeah, that's actually good. Error, possibility, right? Anyways, point being is, if you want to fly an Autopilot drone, then you have to go into the parameter list. And yeah, by the way, this is how you change the settings. You have a search function. You can write, I don't know. Are we moving? Is it? Well, these are not all the parameters though. These are really not all the parameters. No, brother. This is a parameter tree. And then you can see how like army parameters. You have that many army parameters. I think we weren't in all. Were we? Okay, well, whatever. Point being, you will have a bunch of stuff, a bunch of numbers, there's a bunch of parameters, a bunch of shit. And you can take a look at the gauges, you can, all of this shit is kind of difficult to navigate. Very specific. And most of the parameters make no sense in the naming. Like, the names of the parameters make no sense. Oh, we just did this. That's cool. What was that? Well, yeah, status. These are most of, no, I can't even fucking use this thing. It's supposed to be professional. I don't know if these are all of the parameters that it has right now. I think there are more. I think these are just all of the ones that it communicates over public with the computer. Okie dokie. That is Mission Planner. It does have a little bit of GUI elements built into it. Oh yeah, and that's the mission planning itself. The Mission Planner. Like plan a mission. You can, I don't know, write fast. Write that fast. You can do all kinds of shit here. What you can do also is not have a wire here, but have a radio here. You plug in the radio into here, plug in the radio into this thing, and the thing is flying, and then you can also be here, boom, 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 typing shit, changing parameters, seeing your drone just fly off because you fucked up the home point, and then, then that is a ground station. That's it. That is as simple as it gets. At that point, it becomes a ground station. Now, technically you could have also all kinds of cool shit like antenna tracker on the ground station and so on and so forth, or tracking antenna. But yeah, what did I want to show you? Last thing, arming trick. So to correctly set up an RD pilot drone, if you want it to fly, you have to do the arming checks to 0, because if not, there will be an arming check that will have fired off and it doesn't want to arm in some way. Why? There is no answer. There will be never an answer. Usually it's by default on this. If you are really ballsy, you do this. If you're a professional, then you choose and do the ones that you need and you want. And then always remember to write the parameters. Alright, that's mission planner for you. And argue about. You have a thing that's called px4. And px4 is nicer. At least so. It has better documentation. Okay, yeah. When you don't know what the fuck you're doing, don't worry. There's documentation. And documentation is massive. I don't even know how to do it like this. Well, what you usually do is you ask, I don't know, let's say you're yeah, that's what you'll usually do. And then you go here. There are some default things. Here you can see how the default UARTs are set up. Now you can change all that. You can also program article from the bottom up. Sometimes I feel like it wants that. But yeah, you have some special things, some word specific stuff usually here written down, but then you have a bunch of shit that is not word specific. Probably would be a good idea to read all of it once in life, but maybe don't do that. Yeah, it would probably help diagnosing problems in the future. Like, oh, you have a problem. Usually you don't know what the problem is until you start thinking. Okie dokie. That's mission planner. PX4 has nice and quick. And apparently it works a bit easier. That is it. And the third difference between RDCloud and PX4 is if you write custom code for PX4, PX4's licenses are a bit different and you don't have to share this custom code with everybody. So companies that want to do some special things, like, I don't know, targeting systems, use PX4 instead of RDCloud. That's it. That's kind of, yeah. Also, they have a deep ending. Propellers. Right. You're gonna get this part. Is it very nice? Not the problem. Propellers. Let's start actually talking about some of the physical stuff. For propellers, I'm just gonna fucking show you a shop page. There's a bunch of propellers, and main thing how they go by is diameter. That is number one, and then you have the second number that is pitch. It's a theoretical pitch. Pitch, I don't know. How many did you get what the fuck the pitch could be? I'll show you. Then, and then, yeah, how many blades do you have? There aren't many monoblade propellers, but you do have a lot of bi-blades, tri-blades, quad blades. Those are the most popular ones. Then there are some stupid, idiotic ideas like the silent propeller that everybody was posting on YouTube. There was actually a drone company that built one. I don't know, that's it. They built it. Like, they produced it. Nobody bought it. It was terrible. Nobody used it. So yeah, propellers are kind of cool. The funkier it looks, the more you want to get it. But it is quite often the worse it will perform. propellers have to be balanced. That is the main thing. If they aren't balanced, it doesn't matter how good they are. And if they aren't balanced, you might get a lot of different issues. Well, they will seem like different issues, but it's actually just an unbalanced problem. So I quickly wanted to show the diameter and then you have the pitch. Pitch is basically how much of an angle of attack it has. This is theoretical pitch, so it kind of works like this. Okay, let's say you have a propeller. I mean, you do something better. Boom. Okay, this is propeller. So you have diameter. Let's say we're talking about something super popular. Let's say 5. It's inches. Why? Oh, fucking no. Is it 2 things or was it 1 thing? It's in inches, and there's even a funnier thing. Quite often, it's in inches. It's quite often. Well, some companies say 50. Now, there's also another thing. If you go down to small sizes, if you see 30, quite often this is not in inches. It sometimes is in millimeters. There was a semester project group that bought a motor for a 3-inch propeller, and they bought a 30mm propeller, and they were thinking that it's a bit weird and odd. Yeah, so check your fucking, what are those called? Units, yeah, nice. Okay, this is why I like HQ props. This is a company that makes props. They set out a very simple naming convention. So you have 5 for the diameter. I'll also show you the second naming convention. Then you have, let's say you do 1 rotation. Boom, no. Fuck, that's 2 rotations. That's against them. Point is, how much, in theory, it moved up is going to be the pitch. Let's say it's 4. So that's the pitch. 4. Now, technically, you could just get an angle. How much do you need of an angle for it to move up? Now, props, they spin. Controversial thing. So you could think about the fact that was radius. So you can think about the fact that the angular velocity is going to be constant, and the velocity of the prop is not going to be constant. This is the prop blade. That's the blade, right? So the velocity is not constant on the edge of the blade. So the blade is a constant on the side, on the length, rather radius. So that's why you have some weird funky shapes, like this is my favorite one, Emacs. You have the 5-inch blade. The divide blades would be also super great, right? Yeah. But these are the newer ones. These are the older ones. Here, oh, we have them actually drawn. They look so weird. They're like 45 degrees middle, like super wide, and then they go on like super thin, like super long. And it's not even like a nice. By the way, super high efficiency of this. With the Emacs motors, when we started running 6s, like it's insane. I flew, I think, with these for like 20 minutes on a 5-minute run, just like chill it around. No, compared to HQ. Oh yeah, the bullnose as well. Yeah, point being, sometimes funky shapes works, sometimes funky shapes don't work. The smaller the pitch, the more efficient it will be, kind of crazy. But also, the less air it will move, also crazy. The longer the blade, the slower it has to rotate, and the smaller the pitch can be. Also, yeah, something like this. I'll show you. There is like a balance thing that is constantly running in your mind with the motors, ESCs, props, and batteries. Because that's the power drain of the drone. Yeah, so that's the pitch. And then you have the third one. Sometimes you don't. I'll show you which companies do and which don't. And that one just, it's the amount of blades. I don't know. Blade number. Blades. This is a bi-blade, so that would be like 2. So it would be 5x4x2. That's a 5x4x2 prop. I don't know, that helps. It does describe something, but didn't describe the whole prop anyways. So that's kind of how you work. And then there's the second naming convention, which is this would be the 50-40 bi-blade. So it's either the 5x4x2 or the 50-40 bi-blade. That's props. You are a prop expert. You definitely know which prop to use. All of you. Alrighty. Yeah, there are some extremes that I can tell you. Bullnose props. Bullnose constant pit. Like, we have to show them. This is a legitimate thing that existed. Oh my god. These were not the worst defenders. There was the 3 inches, which was just like a slab, not a slab. And those were like one of the first things, I'm sorry. Those were one of the first things that were actually flying in. You know, they actually worked surprisingly well, right? Like, for what it was alright. It worked. What else? Okay, props, I think we covered props pretty much. Perfectly. Oh, these ones are those. So look at this fucking thing. It's a shame. And it's not like it was like, you know, one-off or something. Like, this was kind of commonplace. Like, this is a prop that okay. Really? No. We're going until 16:30, no, 18:30. Yeah, 18:30. I do have to quick it up a bit. We just went over it. BLDC motors. Most of the motors that are ran on any multi-rotor or anything that needs high power density is going to be a BLDC motor. I think BLDC should be the highest power density. What I mean by power density is pretty much how much power can you get out of as little mass as possible. You have permanent magnets on the outside of the. Now, okay. There are outrunners and inrunners. The difference between those is where are the permanent magnets. On an outrunner, the permanent magnets are on the belt. You call this the belt, and then you have. So this would be the belt. And then you have the stator, which is the inside part. Stator, static, it has the electromagnets. You're not spinning the electromagnets, you don't need coils. Yeah, coils electromagnets. It's just pull. Just simply put, it's an electromagnet. It has a metal thingy core, this special fucking thing that you have to make. You don't have to make it, but for as high efficiency as you can get, basically as high power density as you can get. You want it to be able to flow magnetic flux as good as possible. And for that, you need to stack metal plates, super thin metal plates, with a little bit of dielectric in between. Super compact.
That's to reduce eddy currents.
Yes. It is to reduce eddy currents, which in turn lets the magnetic flux to flow. And then you basically have a wire around it. There were some motors back in the day to flow the electrons quicker around. They actually had silver wires. I still have them in my place. There's also silver plated coil wires. You don't need that shit. You just need a decent stator and a decently designed motor for it to function good. These are quite expensive to make, so you won't see them in, I don't know, turbines. You'll probably see something that is without a permanent magnet, because a permanent magnet is just fucking expensive. But yeah, that's why you can link the components for drones are kind of cool, because you can see some exotic materials for it, even on these. Then you have the shaft, kind of self-explanatory. These are usually made out of titanium, just because you don't want that thing to bend and or snap. What else about the electron DC motor? Now we can get into the theory. Well, and yeah, you have this little pad thingy for the prop stops. So back in the day, you didn't have those. You also want, if you're running, one more thing that I would want to point out is these motors for like high performance stuff are always overrun. If you're gonna sit this thing on the bench, put on the prop, and pull the maximum it could technically do in an airflow, it's gonna burn because it doesn't have the airflow actually. But at speed, it will have the airflow, it will cool itself down. It's kind of difficult to test. The perfect conditions would be a wind tunnel that could actually achieve the speeds that you are flying at if it's something very fast. That's why you see the open top. The open top is there for flowing up through there. You don't want anything on the bottom. That's why you see there's nothing on the bottom. There's just 4 mounting points. You could deal with 2, in my opinion, and have it on the top and just flow there through. And that's how it pulls. Now, for something bigger, you would usually see closed bottom, closed top. It has a different system. Usually, it's used by just spinning the motor. Just has, because of the spin, you have flow of the air, fucking flows it out. It's enough to cool most of the things, but that is going to be not overcooking really the motor. Anyways. These are some of the parameters that you will see. Most important parameter of the motor, well, there are 2. It is the kV number of the motor. This is an arbitrary thingy. We can go into it. A kV of the motor is basically, let's take, I don't know, 25 volt battery. You have 25 volts for the voltage. And you have this for the kV. Then if you want to get, and you're getting always the RPMs. To get the RPM is going to be 1 just multiplied by the other. So 25 times 1500. And you have, I don't know what that is. Can someone calculate that? It's definitely going to be over 2,500. Maybe also over 25,000. Super. 37. that's gonna be enough. Then you can take a look at data sheets for the props. You don't really have those, but if you would, and just see how much thrust you can get out of the prop spinning that fast. Another thing to keep in mind is the stator size. So the stator size is, I'm gonna take something that is in my mind right now. I'm gonna say it's 2207. Is there anything else written on the thing? Motor dimensions. Yeah, it is the motor dimensions. It's weird. It doesn't matter. I'm gonna use the 2207 motor. Basically, what it means is that's the stator, where you have the coils and the electromagnets. Doesn't matter, but we approximate it as a cylinder. The diameter of it is 22 millimeters, and it's 2207. And the stator height is 7 millimeters. The stator size kind of shows you how fast does the motor pull and how much heat can dissipate. This changes very much by the construction of the motor. If it has an open top, closed top, are you having a lot of airflow? Did you put it onto a stupid ass frame that has plate right underneath or not? So can the air actually move through it? But usually you have something that's recommended for each motor size, prop sizes that are recommended, and voltages for them. Yeah, the rest of the things are useless. I mean, they're not useless, but they're just arbitrary. That is kind of the BLDC motor. Now let's get into the electric speed controllers, and then I'm going to go over the theory quickly, how these two things come in together. I'm going to take off this. Do you have some money? Do I have So the ESC has, what it does, it just turns on and turns off the electromagnets in the BLDC motor. So you could ask, when does it turn over? Like, when does it switch? I'll show you later. I actually think that I found a good picture. Yes. So it has MOSFETs for switching. Those are the big black thingies that you see here. That is the fucking most of the losses there of the power. You need to pull those things. These things are also quite often overrun, so you want to place ESCs in places where you have airflow, or put heat sinks on them, or something that can heat up for bursts and stuff like this. Then you have microcontrollers for controlling the MOSFETs, and then you also have the MOSFET drivers. What it does, I don't know, who understands a little bit of electronics? Do I have to go into what are the drivers and MOSFETs? Everybody understand what's a MOSFET? Nice. Nobody understands. And yeah, basically you have the microcontroller telling the MOSFET driver when to switch, and the MOSFET driver can supply a bit more quicker and does the switching for the MOSFETs. Yeah, here you can see a 4-in-1 ESC and a single ESC. And quite often you also have a current sensor on the ESC, just to be able to show you how much current is pulled. So how does it kind of work? well, this diagram has a bit different configuration. Point is the difference, you have censored motors and uncensored motors. If you want to spin really slowly and accurately and still supply a lot of power, you quite often want to go with censored motors. For our applications, if we're spinning a prop, we want to usually have higher RPM. We can actually get away with running no sensors, and so most of the motors, well, not most, not all of the motors pretty much have no sensors, and the electric speed controller itself actually checks when the next phase comes. You can see that there's the 6 MOSFETs, and you can see the configuration that the coils are in the motor itself. It's kind of a 3-phase thing. It looks like 3-phase. Thing is, it is DC current. It's DC motors. There's also AC 3-phase, like changing AC 3-phase motors. Apparently, I've heard they get higher efficiency, slower RPM than the VLDs. I don't know, nobody uses it. So you can see that you kind of get 6 configurations of the electromagnets that can be turned on. When it spins, it goes through them, and the ESC in the sensorless motors also have, like, they time it, then they check what the voltage is on the coil itself, and depending on that, they will switch to the next one or not. And yeah, that is pretty much how ESCs and VLDCs work. Level batteries. 2, 3 important numbers you will find is what was the voltage of the battery, right? What's the capacity of the battery? I don't even know what fucking thing I could use for that. And how much power can deliver. Now the power delivery we measure in C rating. I will explain quickly first the first thing. How do you write the capacity? Let's see, but it's not capacity. Doesn't matter. You have, okay, the voltage. The voltage depends on the amount of cells. Here it's written the nominal voltage is what, 22.2 volts. And basically what you have is you have 6 cells in this configuration. So it's a lithium-based cell. So the voltage range that you're kind of looking at, if it's charged, it's higher. If it's discharged, it's lower. Depending on the chemistry, depending on the cell, it will change how discharged and charged the voltage will vary, depending on how much energy you have taken out of the cell already. Also, depending on the cells, you will see different ability of retaining the voltage under load. What we usually want is that under load, it retains all of the voltage, so higher C rating batteries will do that. However, with that comes the caveat of actually losing the capacity of the battery. So it will be a heavier battery for being able to discharge faster, and that's kind of the trade-off that you're looking at. Yeah, so the capacity is milliamp hours. Yeah, I don't know, that is a 1200. I wrote down a 1500. So you can multiply those 2 numbers, get the watt hours that are in the battery, to figure out how much energy this is stored. And then the C rating. The C rating basically is this. A C rating of 1 would mean that you can discharge the battery in 1 hour. Now, this is something that is rated. You could probably discharge it faster and damage the cells. You do damage slightly degrade them anyways. So I just said, fuck it, discharge them as fast as you can. And get the highest C rating battery. C rating on most drone batteries is an utter bullshit. 150 C battery does not exist, although everybody, says they have a 150 C battery. It might be able to do that and then never be used again, or be used but just way worse. What will happen after you discharge it at a high C rating is, first of all, you won't get the 1200 milliamp hours that it is rated for. Might be like 900 milliamp hour battery after that. And the other part is, it's gonna pop up. So, LiPo batteries are pouches. The difference between lithium-ion and lithium-LiPo and polymer batteries is pretty much the construction. Sometimes it's also chemistry, but not too much. LiPo batteries are in pouches. They get way better, like they are way better at cooling. And that's why for high discharge rates, you want to go with LiPos. If you can get away with lithium ions are actually getting very good nowadays, but LiPos will be better at discharging quickly. You will be able to see, you can comfortably discharge them at 60 C and not really damage the battery as much, which is insane. If you divide, what that actually means is 1/60 is that's gonna be the time that you can, in hours, that's discharging the battery in 1 minute. Yeah, if you need something that high, that's fair. Yeah, be something that was 150 C, that's 20 seconds to batteries discharge. I don't know. I've never seen them in real life. I've seen the number a lot, but I have not seen a battery that can just be discharged like that over and over and over again. Now let's go to lithium-ion batteries. The difference is lithium-ion batteries are rolled, they're way more dense, so they will often have, for the same weight, they will often have a higher capacity rating. And that means that you are able to fly or drive or whatever way farther quite often with lithium-ion, so if you want something a little bit more efficient, and if you can't get away with using lithium-ions, do that. If you want something that is the highest performance or the fastest thing ever, go with LiPo. That's kind of how you go around it. Lithium-ion batteries, those have a maximum C rating. Yeah, that's something like that.
Do they have BMS internally or do we need one outside?
Most of these things don't have any BMS. You charge rechargers, that's why you have this. Oh yeah, that's actually a good point. So let's say you have, I don't know, an end. Yeah, an end fucking, let's say you have 3S. 3S battery. So you have 2 big ports that you will use probably for power. Big minus, big plus. And then you will have another lead that is gonna have, we call it the balance connector. That's gonna have every single one of the connections to actually accurately measure the voltage between the cells, so you can actually charge them balance sharp. The chargers that we use are balance chargers. You have to plug in both of the leads to be able to charge them. So you can see that here you can measure the potential across each cell. This battery that you see on this picture is actually, oh yeah, also battery configurations. It is a 6-cell 2P. That means that it has 2 cells in parallel. If you have cells in parallel, you don't have to balance charge those. So you can just add, let's say this is a 3S. Right now it's a 3S 1P. If we want more capacity and the same voltage, we can just add 3 more cells in parallel. 2, 2. Whoop, whoop. Boom, boom, boom. And just connect them here. This will still be able to be balance charged. It has 2 cells in parallel and 3 in series. So that's kind of how batteries goes. The parallel, yeah.
If you don't have an EMS, how do you make sure that you don't go like below zero voltage or?
The flight controller has usually a voltage sensing pin, or the ESC does. You have to make sure that that doesn't happen with the software yourself. You also, because there are different battery chemistries, the lithium-ion batteries can be discharged to like, some of them, like most of them are like 2.8 volts per cell. Some of them can go even lower to 2.4. If you're gonna do that with any LiPo, it's gonna be totally done. You could still get light out of it. I'll show you that later. Usually the chargers don't allow you to charge something like that if you're going to try to charge a LiPo battery and it sees something like that. It's going to be like, oh, a cell error. On LiPos, the golden rule is above 3.3. So 3.5, 3.3 is usually where you want to end your endeavors with the battery. If you go lithium ion, depends. You want to check the cell. I'll show you another shot. And it's a bad banger. You can get really good cells here. Yeah. Also, lithium ions are, because they're old, you usually have a standards for the sizes of the batteries. The 2 main standards are 18650s. I will explain that quickly. We have a cylinder again. 18 here, and we're in Europe, so it's millimeters. And 650, I don't know why this is decimillimeters. 65 millimeters. The 21-700s, same shit, 21 in diameter, 70 millimeters. Actually, I have no idea when they use 5 digits. And then you have also 18 350s for applications that you need smaller. So usually, no good batteries can be found in those. Let's go take a look at 21-700 that is decent. English, Europe, English. Z. Let's say current discharge. I'm gonna get probably. Okie dokie. So these are. Yeah. Okay. So 125 amps. They lie. They all lie. Yeah, but these are those silver. Yeah, 500 million power, 4,000 million hours. Power stock. Those are good cells, probably. What will you see? Where's the minimum voltage? not even written here. Should be. Oh. Nice. Fully done. Which one was the one that we got? Just green. Yeah. You don't, quite often there's not good documentation for the ship. Yeah, this one says that it's,
Each battery has their data sheet from the manufacturer.
yes. Sometimes you can find it, sometimes you can't. So this one would be 2.5 volts. About 2.5 volts. So we probably won't land around 2.6. You have to also consider voltage side in the cell itself, so probably when you're in the land, it's going to be like 2.7. That's kind of how it works. Radios. Those are the controls of radios. Should I explain anything more? Perfect. So, yeah, well, now we're going to get into radio systems and so on and so forth. If you have a radio, I'll use mine. Oh, fuck. Let's make sure it doesn't make weird sounds. Okay, nice. Point being is you have an internal radio module. Usually it has one frequency band that can operate there. And then you have a receiver. On the right side, you see the receiver. We had a receiver on that thing. It was cut off. Useful receiver. But like this, you can see this and that. This is an antenna for the receiver, and the receiver is just in here. It is. You can see by the length of the antenna, this is 900 megahertz that it's going to operate in. You need a compatible TX and an RX module. Quite often they are transmitting also from the receiver side. You call that telemetry, and it can have all kinds of data on it, or none, if you have some specific different protocol. Now that is communication between the radio, or we call this the radio, the controller, and the drone. You also will see, I don't know, most popular ones are 900 or in Europe 868 and 2.4. You can usually also shift these with firmware changes by flashing the firmware to like 2.1 gigahertz, 2.6 gigahertz, and same goes with 900 megahertz band. Now, if you are starting to ship stuff, your antennas become less and less effective, but that one we will not talk about here. These are the most used protocols for the controller and drone side. These protocols are meant for sending only this data and this data only. So it is usually very fast, very light protocols. ELS crossfire goes for, I don't know what to do right then. These are all protocols, crossfire and ELS. ELS is using crossfire to communicate with other things, but what it sends, it's its own shit. And what can I say about this more? It's usually just one UART that you hook up on each end. It's just one UART, and it sends over a bunch of, like, it's a slider, so you have to send out a bunch of data for rudder, throttle, elevator, and aileron, but then you have like less data on the switches and stuff like that. Usually if it's a 3-position switch, you can also get it to literally just send three different things. And now telemetry radios, did I put a picture? No, let's see. Telemetry radios are super plug and play thingies. Those are just radios that plug into your computer and allow you to do what you usually do with the USB cable and connect, let's say, to a ground station, to a mission planner. They allow you to just connect with the drone via different protocol, usually Maplink, and communicate with it afar. That's it. Usually they go in 433 megahertz, sometimes 900 megahertz, and they are very useful because some of the calibration on the drones needs to be done with the drone like pretty much being flight ready. You're gonna have a computer right next to it. You can't do a magnetic drone. The 9 meter calibration, the computer's going to throw it off quite a lot. Also, you need to move the drone around for accelerometer data, and it's all just nice to be able to fully communicate with an autonomous drone without a wire. So that's why you have telemetry radios. Now, FPV stuff. This is if you need video feed, you can either use over the internet digital stuff, some proprietary digital stuff, or one of the most used standards is analog. This is usually done over 5.8 gigahertz, and you have analog video cameras, and analog video transmitters, and analog receivers that hook up to a monitor or to goggles or to whatever. You do sometimes want to have some, these are the transmitters. These fuckers also get really hot, really fucking hot. Turn on power, turn down the power if you're working with these. They usually have something that's called pit mode that comes from racing, not blast some other flyers in the sky when you plug in. But the point being is, this stuff transmits a lot of data. It's analog. The transmission in the spectrum, let's say you have a spectrum, frequency, I don't know, 5, 9, 100, from like 5, 6. Let's say you pick a channel that is supposed to be perfectly 5800. The VPX is going to blast it like, a nice bell curve somewhere around the middle. Should be 5800. But if there's someone close, it is all analog, so it will overlap. You will see the other people's videos and stuff like that. You can actually, some of the, what do you call them, CCTV cameras are also in analog, so you can actually pick them up, often with your goggles, go and browse in parking lots. That's also why we are using FPV, this band and this stuff, because they were used in CCTV, and because the technology was readily available and cheap. People started making more powerful VPXs, and just using CCTV cameras slowly started making also special analog cameras for drones. What can I say? And another thing that I want to touch up on is, I'll erase this. Another thing that I want to touch up on, because it's going to be very important for you guys. If you do wish to run video, and if it is analog, most of those things are usually yes. And you want also some data for the pilot to be visible on the screen, then you need another thing. So you have a camera, beautiful camera. You have the VPX. For this thing, it's also super important. You have the antenna. The antennas are super important. What? So you usually have some kind of data pin to the flight controller. This is usually one-way communication to the VPX. It just tells the VPX in what channel or what frequency frequency to transmit. Very often very finicky setup. I don't know for me. I get this quite wrong quite often. Then you have one wire running the video. Because it's analog, it's just one fucking wire. It's beautiful. It's nice and simple. Unless you want OSD. And that's where this thing comes in. So if you want to display some information on the screen, then you have a chip that's called on-screen display chip. That you have to hook in between the camera and the VTX. Now this thing will have everything, all that you want to display. So you need a UART to connect it to the flight controller, and the OSD chip is gonna be able to be configured through Mission Planner or Betaflight, and then you can change some stuff. I don't know, do I have like DVR to show you how it kind of looks? Oh, look. Don't grab it. It was my race blood, dude. So here you can see some examples of the OSD working and stuff like that. So the white text that you see, that is the OSD chip printing on shit on the analog signal, and then you get that signal to go to the VTX, pass through there. The two little bars on the left top side, those are, it's basically a measure of BPM that it sees on each antenna. This is done on the video receiving side by the video receiving module, or VRF. You have basically another antenna, VRX, and then you have like some kind of monitor. It's analog, so we'll show you some funny crash footage when you lose the video. But yeah, so you can see how the video is. The video feed isn't great, but it is what it is. And here you can see it can display a bunch of different information from the like max speed 11 kilometers an hour, altitude, battery. It has the end battery, that is very important compared to the minimum battery, because quite often it's not the same. Because the minimum battery is under load, and the end battery is not under load. What else? Current, all kinds of shit from the flight controller. So that's the third and final radio communication. I don't think that we have much more. Yeah, that's how the video receiver can look. You can have them in all shapes and sizes, but quite often they run one that. Why two? Because then you can have one that is an omnidirectional antenna, basically it doesn't care where you are in the sky. It has same receiving power in all directions, and then you have a directional antenna that is pointing at where you want to go far. You can have those. I think we're going to talk about antennas a bit at a different time. That's kind of how the video system looks. On the ground, you have a VTX, an antenna, and then camera. And then you can put an OSD chip in between. The OSD chips are usually built onto the flight controllers, so it's just a wire that is like a camera wire. You route it to the flight controller, and then you have a VTX wire that's going video VTX that goes to VTX. Frames, yeah, carbon. Carbon, there's a bunch of shit about shapes and sizes, and this is a normal, what do you call it? It's like freestyle Spanish, right? Yanni loves this one. I like Chico, but this is really good carbon. So this is quality of carbon, really important part. Geometry also a really important part. Basically, you want the spread to be as stiff as possible for it to have vibrations as high as possible in the frequency band. Because if it's high frequency oscillations, then you can filter those out compared to the low frequency oscillations or just your movement in general. So then you can differentiate from your movement and your stuff that is that's not part or not. Bigger stuff, usually more motors, more features in terms of storage, shit like that. I wanted to get into GNSS. How are we? Who wants to get home? Nobody. Get 2 people. Okay, GNSS. I'm gonna super quickly go over it. You have GPS, that's American, Galileo, European, bonus, and they go on never use that thing. Although no, sometimes they do catch data as well. What it is, it literally just sends out a time stamp. And another thing that it knows is where it's at. So with those 2 things, you can actually calculate where you are at, because you know how far you are from each other satellite. So it's basically a simple triangulation with a little bit of relativistic effects coming into play. I think this diagram kind of, it's mostly for RTK. But yeah, GNSS, or just GPS modules are used a lot in drones for just knowing where the drone is. So you would have an antenna that has, we have it here actually. So this is the GPS module. Quite often they come with also a compass on board, sometimes with temperature gauges as well, and shit like that. And what they do is they just know where you are. That's it. You connect the UART for GPS data, and then you connect as well an I2C for the magnetometer data. Remember to reverse the UART course, DX to RX, RX to DX, and you're kind of good to go. GPS is not super accurate, so if you want higher accuracy, there are many sensors you can kind of start looking at. RTK is a system that is basically on ground. You have a fucking thing on the ground. It will basically make another beacon of a GPS thing, but more local. So it has higher accuracy, pretty much, a lot higher accuracy actually, and then you know where you are more accurately. So that's RTK. Any questions about GNSS? Because that was really a rush over. But yeah. Cool, yeah. Then you also have some CAN GPS modules that run on H7. Point is, you can have multiple GPS modules on the same drone as well to try and get even better data and stuff like this for more autonomy. But it's all just a receiving antenna. So, yeah, I don't know how to tell more about it. Just simple, just gives you the location. On the left, you see the ones that are usually cheaper. They work good. If you want to look for something that is M10, don't buy anything nowadays that is M8. There's no point. M10 is basically the chip that is used for the calculations on board of the GPS module. And then you see the little PCB antenna on board of the module. And yeah, that is pretty much it. So those are most of the drone parts that you're gonna use. There's some other sensors, I think we should leave that to another time and talk about some special sensors, because those are way more in depth, and you can't really glance over them as part of this. But yeah, thank you. Good night.